Now, let's look back in time, quite literally, because and I'm going to have to get Seanie Morris's help on this, the CEERS project. It's a survey which has availed of the James Webb Telescope to look at a galaxy that existed only 570 million years after the Big Bang. And just for context, how long after the Big Bang are we at this moment, Seanie?
We are at 13.7 billion years, give or take 200 million years.
All right, so
that's our calculation.
This would be very early stages in the universe's development compared to where we are now.
That's correct.
And how are we able to look back in time?
The James Webb Space Telescope it's a phenomenon of technology. We've been able to make a telescope that can look past all the kinds of obstacles that we would have in our view, if you like, in optical light. So by using infrared and a little bit of other frequency waves to which they can combine, we're able to peer through the gas and dust that would lie between us and objects further and further back in time. So James Webb's detail of what it has been able to see, not even just locally in our own solar system, giving us views we could never have anticipated before, going back in time to when we are looking at galaxies as early as 470 million years after the Big Bang.
So just so we understand the principle, when we see stars in the sky at night,
yes,
there is a delay, there's a lag, because the speed of light, it takes time to travel here.
It is like time travel.
And is it the same principle then with the infrared light that it has taken so long to reach us?
It is essentially the same. It's what we see as light is part of the electromagnetic spectrum. So that goes with microwaves, radio, infrared, which is your heat signature, visible, ultraviolet, X-ray, gamma ray, and there's one more, I can't remember which one it is, but they're all part of the electromagnetic spectrum, but we are sensitive to what we interpret as visible light. We need to go beyond visible light to see even further detail. So when we observe things like the sun in infrared, we see far more magnetic interference and constructive and destructive magnetic lines and sunspots than we do with visible or through heat. So James Webb is taking these other frequencies that lie just out of the realm that we can detect, that would be interfered with by dust and debris, and is able to then go and eliminate that noise. Let's call it noise. It's like the pixelated noise of a bad photograph.
So it's a marvel not just for its sensitivity in picking up such ancient light, but also for filtering it so we can interpret it and see what would have been a galaxy billions and billions of years ago.
A cosmic baby, basically.
And
yes.
Do we know if this galaxy still exists?
We don't know right now because we are seeing that light as, if you do the maths, roughly 13.2 billion years ago. Light does travel at a finite speed of 288,000 kilometers per second. That's from Dublin to New York and back 35 times in 1 second. With regards to looking back at the early universe, these galaxies are there, but we're looking at it where the light set off at that point in space and time. That galaxy has moved. And you and I even touched on this before with regards to the sun. To say we see the sun in the sky right now where it is, but that's not where it actually is. That's where we saw where the light left 8 minutes and 40 seconds ago. So it has moved to the right a little bit since that.
Well, let's hope it's still up there.
Yeah. So these galaxies, the thing about the survey is that it has detected that this one galaxy, CEERS 1019, has got a comparatively small galactic black hole at its core compared to the other early galaxies that have been measured. CEERS, by the way, is the Cosmic Evolution Early Release Science Survey. That's what the acronym is for.
So the galaxies discovered under this project are going to have CEERS, the acronym, beforehand.
So this particular galaxy, of which there is a photograph of it on the web, released by the University of Texas in Austin, Texas, is CEERS 1019.
And does that mean there were 1,018 galaxies discovered before it?
I'm guessing perhaps, yes. Or other entities. They may not all have been galaxies because quasars, which are an early form of galaxies, they're part of the catalogue as well. But we might have detected gas clouds, nebulae, in early filamental structures going way back.
Clearly, 1019 is noteworthy. You said because the black hole is less massive than would have been expected, and that's significant. Why?
Well, at the heart of nearly all galaxies, after they've essentially formed, because you got that cluster of energy and pressure and weight, a black hole is the phenomenon that keeps the galaxy turning, keeps it together. The Milky Way has one, and its weight is roughly 4.6 million suns. Its mass is what to call 4.6 million solar masses. This galaxy, 1019, its mass, the black hole's mass, is roughly 9 million solar masses. But the other early galaxies that have been discovered, they got black holes at the center of themselves much larger, much, much larger. So we don't know why this one is quite small. That's why it made the news headlines. We've discovered such an early galaxy, 570 million years old, but has a very comparatively low mass black hole at its center, and we don't know why yet.
Interesting question. So we can look backwards in time. Is it possible to go the other way, to see the future?
I'm not entirely sure. This is where we're going into the realm of cosmic physics and quantum mechanics, quantum physics. It is theoretically possible. But I think on a Friday morning, that might be worth a conversation on a Monday morning instead, when we can brush up on our quantum mechanics.
Right.
There is a theory that with quantum mechanics, you can exist in two places at one time. So it's to do with manipulating particles at the same time in two different locations in space. And that can allude to looking forward at a point, rather than always looking back.
It's radio, so you can't hear my blank expression. Suffice to say, the coffee is not nearly strong enough for that conversation. But I think it's a different principle anyway, because if we're seeing light, infrared or otherwise, on a delay, that implies looking back in time.
True.
Looking forward, I'm afraid you're on your own for tomorrow's lotto numbers. But in the meantime, the Midlands Astronomy Club, always eager to hear from new members.
Yes, keep in touch with us through our Facebook page. We've wrapped up our public lectures for the summer. But we will be getting back in touch with people in August, because the Perseids meteor shower will be peaking over the night of the 12th of August. And that always is a highlight, not only because it's summer, but because it's a very rich meteor shower. And all you need is a nice easy chair and a Mark I eyeball to enjoy it. So we'll be touching on that in the future.
Good stuff. Seanie, thank you very much indeed.
Thank you, Will.